This lesson will focus on function notation. When we say that y is a function of x, we can represent that algebraically as y equals f of x. That looks like f times x, but that's not what we mean in this context. In this notation, in y equals f of x, note that x is my input value, y is my output value, and f denotes the function rule. To evaluate a function means to find the function's value y at a specific input value x. We do that by substituting the input value in place of the variable and then simplifying. It's important to note that f of x equals y corresponds to the ordered pair x comma y. In example 1, we evaluate the function f of x equals 2x squared minus 3x plus 1 for some given values of x. Now again, note it's important to remember that f of x is just another way to write y. We could have just written y equals 2x squared minus 3x plus 1. But in mathematics, we like to use symbols and abbreviations. And this function notation will actually help us when we're trying to evaluate a function. Part A is to find f of negative 3. We could have said evaluate the function 2x squared minus 3x plus 1 at x equals negative 3. But rather than having that much language, we will just abbreviate that to say find f of negative 3. The input value in this case is negative 3. My function rule is f, that is what I'm substituting into, and the output from that is the value y that corresponds to this input of negative 3. What I like to do when I evaluate a function is replace the variable in the original function with parentheses. We write then 2 parentheses squared minus 3 parentheses plus 1, and now we will input that specific value of x, which in this case is negative 3. Then we simplify to get 2 times negative 3 squared, or 9, minus 3 times negative 3 is plus 9 plus 1. This is 18 plus 9 plus 1, or 28. F of negative 3 equals 28 means that the function has a value of 28 at x equals negative 3. This corresponds to an ordered pair. This corresponds to the ordered pair negative 3, 28. To find f of square root of 2, we do the same thing. Put in parentheses in place of the variable x. And now insert the specific value, which is square root of 2. We have 2 times the square root of 2 squared minus 3 times square root of 2 plus 1. Simplifying, the square root of 2 squared is just 2 minus 3 square root of 2 plus 1. 2 times 2 is 4 minus 3 square root of 2 plus 1, or 5 minus 3 square root of 2. Again, this corresponds to an ordered pair. When the input value is square root of 2, the output is 5 minus 3 square root of 2. We are not restricted to just inserting numerical values for the variable in our function. We can also substitute algebraic expressions. We'll get into this later on in more detail in another section, but to find f of a simply means In place of that variable, so wherever you see the variable, put parentheses. Now insert what is inside as our input. Our input in this case is a. So we have 2 times a squared minus 3 times a plus 1, which is just 2a squared minus 3a plus 1. And the last example is to find f of 3 plus z. So here again, we put in parentheses where we see the variable to get 2 parentheses squared minus 3 parentheses plus 1. We insert our input, which is 3 plus z, and simplify. Square the binomial 3 plus z. You can multiply that out if you need to, but that would be 9 plus 6z plus z squared minus 9 minus 3z plus 1. Distributing the 2 gives us 18 plus 12z plus 2z squared minus 9 minus 3z plus 1. Combining like terms, we get 2z squared plus 9z plus 10. Example 2 is to evaluate g of x equals the square root of 6 minus 2x for the given values of x. In the last example, our function was named f. In this example, our function is named g. We can use really any letter to represent our function. So if we want to find g of 3, we will say that is equal to the square root of 6 minus 2, and there's a variable, so put parentheses in place of that. Now substitute the input value of 3. This is the square root of 6 minus 2 times 3, or the square root of 6 minus 6, which is the square root of 0 or 0. So our input value of 3 corresponds to an output value of 0, which is the ordered pair 3, 0. To find g of 4, we do the same replacement. We get the square root of 6 minus 2 times something. Our something in this case is 4. We get 6 minus 8 in the square root, which is the square root of negative 2. This is an imaginary number, but for functions we are wanting a real number as an output, and so we would say that g of 4 is undefined. That is, that 4 is not in the domain of this function. G of negative 4 is the square root 6 minus 2 times negative 4, which is the square root of 6 plus 8, or the square root of 14. So our input of negative 4 corresponds to an output value of the square root of 14. The last example is g of 2w. We get the square root of 6 minus 2 times whatever our input is. Our input is 2w. So this is the square root of 6 minus 4w. Let me know if you have any questions concerning function notation.